Hi, I'm Bill. Welcome to the channel. If this is the first time dropping in, thank you. If you're returning, welcome back. It is the 4th of February 2024, and in this video I'd like to share with you a few details around how I captured the data and how I processed the data for IC1848, also often referred to as the Soul Nebula. And it was captured with my RedCat 51. So what you're going to see now on the channel are two different playlists. One will be images that I've captured with my Edge HD8, and then there'll be another playlist for images that I've captured with my RedCat 51. But before I get started, it's dawned on me, I'm exploring the deep sky, deep space in a sense. What do I know about my Earth? Our Earth. So recently I came to the conclusion that some of the areas that I've been imaging from have a very rich geological history. And I'm kind of caught the geology bug. Here is a representation of the 1992 earthquake in Landers, California. And that's exactly where Goat Mountain Astronomical Research Station is located, which is run by the Riverside Astronomical Society, and it's a place where I lease a pad and I often image from there. And then there's the place we image with Patrick and Christian at around the Amboy, California, where it's the Cinder Cone volcano kind of crater, and then even Red Rock Canyon State Park. So this area where I've been imaging is rich geologically, and now that I'm going into Arizona, Alamo Lake State Park, there's a lot of interesting geology there. So I'm planning to make some videos around the geology, kind of as an amateur buff when it comes to geology. Those videos won't be on this channel, but if you have an interest in that, let me know. Write something in the comments that, yeah, you might enjoy that type of content. I will be hosting any videos I do make around geology in this area where I image on a channel called Lori and Bill Retired. My wife and I started this channel a couple years ago around our camper van, so that's where I'll host the content. All right, so let's get into the Soul Nebula IC1848. And I'm also going to go over the workflow I use within PixInsight. So as always, I'm these days putting my images up on Astrobin, and as part of that process, I'll share with you the technical details of what equipment I use, what filters, integration time, exposure times. So let's maybe start there. Again, I use the RedCat 51 Gen 2. I use my ASI294MM Pro camera. I'm a monochrome shooter. The mount at the time was the ZWO AM5. I use basically ZWO filters, HA03S2, and at that time I was using the ASI Air Plus. I don't know if you've seen my videos, but subsequently I've sold those two devices, and I'm using just Nina these days for many reasons. The SI Air is a great platform based upon what your needs may be. And this data was processed using PixInsight, and we'll get into that in a minute. So essentially, here's the integration time, 6 hours and 36 minutes. And here's the breakdown for each filter of how many sub-exposures and at what exposure length. I was basically using 180 seconds as my exposure length for narrowband imaging these days. And I put a note here that it was data was collected under Bortle 4 skies. There's a chance that this data might have been captured at Blue Canyon Airport up in the Sierras. In that case, it would have been a Bortle 3+. But I find it helps if I understand, and I'm looking at some imager's image and they list the integration time. It's always helpful to me to understand how dark were the skies where they were imaging, and so that information is always appreciated. So let's go into, well, let's close this for right now. So here we are in PixInsight. This is basically my finished image. Again, you can maybe see it better if you go to my Astrobin link to see the image. But this is the processed image here. And if we go in and we look at the History Explorer, well, let's just open that up a bit and see what we got here. And so here is my basic workflow. I basically use WBPP, weighted batch pre-processing, weighted batch pre-processing. Let's see if this is the if this comes up here, what we have. Okay, so again, nope, this is not the right data for this project, so just ignore that. But if you've not seen weighted batch pre-processing script, it's where you load your darks, your flats, your lights, and that type of information. And then there's several options that you can set in here for what you want to happen post calibration. All right, so let's skip that. What I wound up with then is integrated images for each individual filter, HA, S2, O3, and then I used, let's get rid of my camera here so we can see Logitech. There we go, take that off. And so basically what I used was, well, I did a couple of things here. Once I had the individual frames, HA, S2, and O3, I used linear fit in the process. So that was a step. And then after I've kind of equalized those channels using linear fit in a sense, then I used combine RGB, a pretty straightforward tool to use. I didn't need to crop. I did not see a gradient, so I didn't use DBE or Grexpert on it, nor did I use the solver, or since it's broadband, I did not use color calibration. If this was an RGB image, I would. I did use, then as you can see here, I used Blur Exterminator, then I used Star Exterminator, and then I used a Noise Exterminator. At this point, I basically had the image, in a sense, stretched the way I wanted it, and now I wanted to make that stretch permanent. So I basically used STF and histogram transformation. And you know, if you're familiar with it, or maybe if you're not familiar with it, you basically, once you have the stretch, the temporary stretch that you want, then to make that permanent, you can just drop this down on this bar here, and then once you do that, then you can take this triangle here and drop it on your image, and then it'll make that stretch permanent in a sense. So then after I did that, I did another noise exterminator run on it, and yet again I did another histogram transformation, and then I used let's open this up a little bit. So, then I used local histogram equalization, basically do 2 runs in local histogram equalization. I play around with this amount here a little bit. You can set a preview on your image, and then you can work with these parameters here. I do 2 runs one with a kernel radius around 40, and then I do a second one somewhere up around 125 to 150. Again, these are things that that you can tweak to your own preference. To me, it's basically trial and error. You can adjust your parameters. You can use the default parameters, or you can play with it a bit and see what your eye tells you works best for you. And then I did a multi-scale median transform, and as part of that I create a mask. Let's get rid of this preview here. And just to show you what my mask looked like, I use range selection to create the mask, using an upper limit and a lower limit. The things in black I don't want to sharpen. The things that are in white I do. I don't really want to sharpen the background. There's really no detail there. So this was my area for the for this nebula that I wanted to lighten. And then also when I did the mask, you can change the smoothness level, and I set it around 13.5. Yeah, just close that. We'll get rid of that. And then let's get back into the history here. Unfortunately, I have to find a way to keep this open. And I should say at this point, Star Exterminator takes the stars out, removes them from the image. So here's what my stars looked like. So that was the stars that were removed. Close that back down. So, you know, again, at this point, the stars are out, and so now you're just working on the basic, the non-star image. To me, it's a little bit easier to see your detail and everything when you do that. And then I did some curves transformation, a little bit of saturation, not too much. Again, when you get into where your image is no longer linear, you're now kind of you're working in the creative area, and it really comes down to what your eye tells you to do. And I tend to be understated. That's my preference for my images. And then using pixel math to combine the stars back in. But when you have your stars separated, let's put that over there. You need to do a stretch, and in the process of doing the stretch, I was able to let's undo that. In the process of doing the stretch, I was able to determine I can make the stars less prominent as part of the stretching. And maybe I'll dig into that if there's an interest in how to do that. Maybe I'll do a video where I just show how I work with the stars prior to combining them back with the image to make the stars a bit less prominent. And then basic simple equation here in pixel math to combine those back up. And then what I do as the last step, I drop an ICC profile onto the image, and then I take that image, I clone it, and I make a JPEG copy which is this image here. So I'm now at the point with PixInsight where my workflow is icon driven. It's been working out very well for me. Again, if I'm doing an RGB image, there's some things that I do, and I'm more likely to see a gradient with an RGB image based upon how dark the skies are that I'm imaging under versus when I'm doing broadband. But you know, we each develop our own workflow and what tweaks we like. But the key thing for me these days, being relatively new to effectively using PixInsight to produce my images, is I don't want to overcook anything. I prefer it a little understated, but again, it's art at this point, so you know, do what really works for you. All right, I think that's about it from that perspective. So let's go back into here. Which one was it? All right, the technical details again will be available on my Astrobin if you'd like to take a look at them. Let me bring my picture back up. And there we are. Okay, if you like this kind of content, please give it a thumbs up. This is my reveal of IC1848, the Sol Nebula. Feel free to leave your comments in the comment section of the video. What would you do different? If you see opportunities for me to improve the image, let me know that as well. Again, I think we're in a really subjective area here when we get into image processing. It took me a while to get comfortable with that because, you know, I felt I couldn't image because I wasn't really sure what it was supposed to look like. But finally, I just sat down and said, it's going to look like the way I make it look like. And, you know, if I've got good data, that's the way it's going to be. If I got bad data, well, that's a whole different story. But, you know, I think I had a block for a while on producing images because I wasn't quite sure what it was going to look like. And I was maybe a little bit, in a sense, concerned on the feedback I'd get. But now I don't really care. This is the current level of my skill set when it comes to PixInsight. I'm happy with the images. This is not a competition. This is really for enjoyment. So we should all produce what we like and let the chips fall where they may as far as what other people may think about our art. So anyway, there it is. I like it. And next year I'll go back, and if I'm still here, I will capture some RGB stars. I'll reprocess this image, take these stars out, which were captured under broadband, drop the RGB stars in, and maybe give it a little bit different look. All right. I hope you're looking forward to some good weather as we quickly approach the February new moon. Looking not so good here. I'm not going to whine. I am going to go out to Arizona. My first night of imaging should be the 10th of February out at Alamo Lake State Park in Arizona. Looking forward to that. Capturing some additional data. Working some more with Tom Palmer's Target Scheduler, which is a plug-in for Nina. And just keep this rolling. All right. Thanks a lot for dropping in the channel. See you next time.